Thank you very much. I'm going to be discussing, I'm going to be presenting some of the work undertaken for this Picato project with Philip Anderson from the School of Engineering, Federica Dragoni and Nico Sava, and myself from the School of Mathematics. And we decided to look at perceptions of undergraduates, of perceptions of students of formative assessment. And by formative assessment, we imply work that students are not necessarily constrained to do. So the ideas behind the project are simply, well, how can we engage students with formative assessment? How can we encourage them to partake in it? And what particular aspects could be put in place to encourage this engagement? So without going into the literature and just and without being too exact, here are 4 aspects that kind of are behind all of our thinkings for formative assessment. In particular, in a constructivist framework, something like mathematics is often only learnable through doing and through getting your own appreciation of the subject. And there's a lot of evidence for that, and a whole part of our project is to look at the literature, but I'm not going to be speaking about that today. There's a lot of evidence for that. But in general, formative assessment, hopefully we can all accept, allows for feedback. Students can get feedback on their work, but lecturers can get feedback on, as educators, we can get feedback if students are missing something that we can assess via formative assessment. And that's what I also imply by identify deficiencies. It's also very important to be able to modify the center of gravity of motivation. So if students are always motivated by examination, by performance, well, why don't we try and move that motivation? And that's something that can be done through formative assessment. But that brings with it a chicken and egg thing. Is that how do we get students to be motivated to do it in the first place? And also, it's important for students to be able to identify personal learning tendencies. I know, for example, personally, when I was an undergraduate student, it was through the doing of homework that I realized that it was repeating things that helped me understand them, and repeating methodologies and really, well, I'm a very constructivist learner, so that's how I was able to identify that. So our main approach was a questionnaire. We designed a questionnaire that was delivered online, and you've got copies of it in front of you, I believe. And as you can see there, we gave out a £20 Amazon gift voucher, and when we sent it out, we had absolutely no idea how many responses we were going to get. Here's one of the questions that was on there. So a lot of them were of this form. Most of them were of this form. In fact, we had 19 statements like this. So doing homework assignments helps in understanding lecture material, and then students could strongly disagree all the way up to strongly agree. All in all, we had 28 fields. So we also asked questions such as which school were they from, what year of study were they in, and there's one particular question that I'll get to at the very end. But most of the questions were like this. And then the work I'm about to present was of a statistical nature, where we were able to identify groups of students. So, for example, students that answered this question as 3, were they different to students that answered this question as 4, or were their answers to a particular question different? And there are tests in statistics that allow you to check that if your results have a slightly different mean, for example, that it isn't just coincidental. And what we have is a p-value, and you'll see that appearing throughout these slides. And when we have a p-value less than 0.05, we can state that something is significantly different. And that's a very standard and well-accepted statistical term. So we had 192 students get back to us. It's actually a slight lie. I've removed certain students that were hard to classify because they were doing a particular type of course and whatnot. But in general, we had 192 students, and you're going to see a lot of graphs like this. So for example, there we see the engineering and the mathematics students, and we see how many students are in each year. So engineering, There were about 33 students in year 2 that got back to us. In School of Mathematics, we didn't have many fourth years, and this is quite understandable because in mathematics, we're only in Cardiff, we're only really getting into 4-year degrees over the past couple of years. So we had a lot of data. We were quite happy. We had 192 students. That's great. We can test a lot of things statistically with 192 data points. That's really good. But it was difficult because we had so much data. And so an initial very easy study to do is just look at all our numeric variables and simply see if we can find correlations between any of them. I don't expect you to gain anything from this apart from the fact that it's hard to gain anything from all this, that there's a lot of stuff there. So what this is called is a correlelogram. And for example, when we have blue boxes, we said there's a strong positive relationship between things. So if you look at 6 and 7, the blue box corresponding to 6 and 7 shows that students who answered highly on 6 in general answered highly on 7. Whereas a red box shows a negative correlation. So for example, students that answered highly on 5 answered lowly on 9. So, but then also the different shadings of these colors show whether or not things were significant. So a dark blue shows that things were indeed significant. A light blue means that, yeah, you could possibly say that, but it's not statistically rigorous. And so from this, we could already gain some insights. So more insights that just reassured us that the questionnaire was answered properly. So for example, we see that students who feel that homework helped with their final mark also thought that homework helped understand the material. And likewise, if students received a mark for their homework, students who are more likely to do homework if they received a mark for it are also more likely to do it if it counts, and vice versa. So we had so much data and so many avenues to look through, we had to really contain ourselves and try and constrain ourselves to only look at certain things. So looking at our data, we tried to identify dimensions that defined a student. And so we said, okay, every student is going to be on one of these 5 dimensions. So their year of study, their school of study, those are quite, well, those aren't subjective, those are quite objective measures. And then these last 3 that are a bit more dependent to the student. So how good they are, and what we use as a proxy for how good a student was how good they felt they were, okay? Whether or not the student felt they received adequate feedback, and how much they work. So these were our 5 dimensions that we could then identify everything against. So for example, we have 2 students there. The solid line shows a student who did not consider themselves to do very well, did not consider that the feedback they received was good, did not do a lot of work, and was in their second year. We've also then got in the dash lines a student who is a strong student, got good felt that they got good feedback, worked a lot, and they're in their final year. So we got a mix of everything, and these were the dimensions that allowed us to continue. Now, when doing this work, and we have so many different questions that we can look at and quantify, we could just list, for example, all the average scores, and I believe but there's a very big problem with averages, as you will see, is that they hide so much variation in the data. They hide bimodal responses. For example, you can get an average of 3 if half our students disagreed with the subject with a particular statement and half agreed with it. So we have to be very careful with averages. But also we have to be we can find, so if all these data points were a particular question, and we can get a finding from a particular question by seeing that perhaps students are more likely to do homework if they're in the School of Mathematics or something like that. But what becomes very interesting is when we can find connections between all these. And this is what I'm going to show to you today, is the actual connections that we were able to find. But I'll start off by showing you some independent findings, and we'll call these minor findings, and then I'll move on to the major findings and some nice conclusions that we got at the very end. So just briefly, these minor findings. I just told you that we shouldn't be talking about averages, but I will show them to you anyway. The employability, we see, for example, that engineering students were slightly more motivated by employability than mathematics students, but in general, the mean was quite low, even though there was a bimodal response there. We asked the students whether or not the only thing the main motivation for doing their homework was the mark they received. And there we actually got quite a low mean, but again, a bimodal response, and nothing that seemed to impact that. So it doesn't seem to show that the mark received had a big influence on anything, which was interesting. We looked at past exam questions. We asked students if they would be more likely to do homework if they were able to, if they included past exam questions. And there it was quite interesting. We saw a statistical significance between year groups. So students in the early years were less inclined to to be motivated by past exams, whereas students in the later years were. And that's an interesting finding that I'll come back to at the very end. Doing work online, there was a slight difference where students in the School of Engineering more akin to doing work online. Again, there's bimodal response there, but in general we would say that mathematicians were perhaps less inclined to do work online. And then the flipped classroom. So by that I imply we asked students if they were more likely to do homework if it was given to them before a lecture on the subject. Because that's how I like to do a lot of my teaching. I lead students to construct meaning before I talk about it to them. And again, interestingly, we saw that engineers are slightly more interested by flipped classrooms. So some of the more perhaps trendy work seems to be better suited to engineers. But again, I think the response for online was bimodal for mathematicians, and for flipped was just very negative mathematicians. So now to move on to the major findings. So I'm going to look through a series of statements, and we're going to understand we're going to see certain connections arise. So firstly, we looked at whether or not students found non-marked homework helpful. And so we've got a distribution there. You see the average score in red, but again, you don't want to pay too much attention to that. You want to look at these distributions, which really show the whole data. And immediately we saw that students in mathematics, in the School of Mathematics, found homework more helpful. That's interesting. But here's something a bit more interesting. We looked at how much time students spent working, and we found a statistical significant effect of this. So, pardon me. So students who worked a lot, or more than 18 hours a week, they all said that they found non-marked homework helpful. Whereas students who didn't work very much, although you do get this bimodal response as well, but the averages go down, and in general, that's where we get the students that aren't that likely aren't that likely to find homework helpful. So immediately we're seeing that, okay, if students work a lot, they find homework helpful. But again, this is correlation, not causation. So that the opposite is also true. We then we looked at so much stuff, and I'm trying to just report the things that were interesting. If we just look at the mathematicians, so we're taking out all the engineers, there happened to be a significant difference between second years as to whether or not they found non-marked homework helpful. And that was quite interesting. And when I point this out to our director of learning and teaching, he actually straight away went, well, yes, in our second year, we have a lot less summative assessment. They only have formative assessment, so perhaps students don't do it. So the main conclusion from that little question is that students who spend more time self-studying find homework more helpful. Now that's a lovely thing that should almost be shown to all our undergraduate students. So then we looked at social learning aspects, so whether or not students were more likely to do homework if it was group work. And we saw significant effects of the maturity of the students, so what year they were in. And students that were in their fourth year are less inclined to want to do group work than students in their first year. So perhaps that points towards the fact that in their first year, students are maybe a bit scared, don't have many friends, and want to do work, whereas in their fourth year, students are just happy to work alone, or perhaps have just gone through the system, know how to work, and don't want to have to work with anyone else. We also saw something interesting here. The students that were stronger were less likely to want to do work in groups. Now I think that's a brilliant finding. Of course, we've got the low groups here But what we were able to see is that basically, yeah, if a student is strong, then they don't necessarily want to do work with a group, whereas if a student is weak, then they do want to work in a group. And that's basic game theory, really. So what we're seeing, if I use the word maturity for strong students and students in later years, that the more mature students do not necessarily want to work in a group, and vice versa. Peer assessments. We looked at group work, but then we thought, well, let's look at peer assessment. And now we see that if students who work a lot do not want to be peer assessed. And so it's almost pointing to the fact that they say, well, no, I've worked so hard, I expect to be marked by someone who knows things better than me. But also, on the opposite side, we see some students, if you look, that don't work at all. There was quite a few students who actually said, well, no, I would much rather be peer assessed, so I don't want my work to be seen, perhaps, by a lecturer. And what we begin to see appearing are two student groups. And I'll start concluding now. And these two groups are like so. We have one set of students who work more, who don't want group work, who don't want peer assessment, and who find non-marked homework helpful. And then on the other side, we have students who work less, want group work, want peer assessment, and don't find non-marked homework helpful. And in general, we have these two groups of different levels of engagement. And it's a very interesting question as to how can we use the motivation of the blue students onto the red students, perhaps. Or indeed, the blue students are the students that are very well engaged in non-marked homework and don't necessarily have a bad perception of it. They're all quite happy with formative assessment. So the question is really what can we do to engage this red group of students more? And it goes back to one of those first immediate findings, which was the students that work more, find homework more helpful, get better results. And so if we can somehow either get a good influence from the blue students or potentially make the red students understand that if they were to work more and show them evidence for this, that might be a way to garner further engagement. Now this graph is hard to get on this slide, but at the very end of our questionnaire, we asked one simple question, which was, what one thing would make homework most appealing to you? Now, we're just highlighting two things here. The first is if I receive a mark for them, and the second is if I get feedback. Now, if we put both those things in feedback, because again, recall, it was clear in our questionnaire that a mark was different to whether or not it counted, and count both those two things as feedback. Here, our students are saying, the one thing that makes homework more appealing is feedback. If I get good feedback, I'm more likely to do homework. And that's not interesting at all, right? This is just a finding that's confirmed in the NSS that students indeed do want do want feedback, and we're rated against how good our feedback is. And some students go through the School of Mathematics and come out at the very end and fill in the NSS survey and say they never received any feedback. But anyway, I told you at the very beginning of 5 dimensions I was going to be looking at: the self-described academic performance, how long they spent working a week, their age, the year, and the school of study. And all 4 of those I've talked about as we've gone as having an effect on students' perception of feedback. But of students' perception of homework. But the final dimension that we also considered in this study is whether or not students found feedback adequate. And that did not come out as significant for anything. So this is quite a nice finding, because by actually looking at the correlation, carrying out these statistical tests, we're able to perhaps identify trends that students themselves don't realize. So whilst any student would say, yes, I want good feedback, and yes, I'm more likely to do homework if I get good feedback, the data and the statistics suggest otherwise. And this comes back to the other question that I think we should always ask ourselves as educators, is the very important difference between what a student wants and what a student needs. And this brings up the problem with student feedback forms, that they might not like a lecturer, but they might indeed work very well with them. I'm not necessarily saying that we should rubbish everything a student says, of course not. But in this particular aspect, feedback does not seem to be something that students recognize as something they want, even though they will say it is. Now, I said at the very beginning that one of the huge benefits of formative assessment is the ability to gain feedback in a bidirectional way. But this coming in from our data set is a particularly interesting finding. So a few more conclusions before we finish off. And connecting to some of the independent findings at the beginning. So it seems that in the early years, a way to encourage engagement with formative assessment is to have more group work until students perhaps become a bit more mature, a bit more group work, a bit more social learning activities. And in the final year, students are more motivated by the examinations, so bring into examination preparation. If we believe, and I certainly do, that social learning is an important aspect of learning, then we do have to point out the strengths of group work, and in particular, we also have to point out the strengths of formative assessment in general to those red students. And this comes back to the blue students, and it would be if there's a way that we can engage the engaged students to have a better influence on the lesser engaged students, then that's something that should be explored. There's a lot more work that could be done in this aspect. Get more data from different schools, see if if our findings only hold to mathematics education. Further understand this difference between what a student wants and a student needs. So perhaps relating this to actual student performance as opposed to perceived student performance. And finally, we've got a huge data set there, so it's a lovely thing to have, to be able to carry out a lot of statistical analysis on it. And at this point, I would ask for any questions and leave this comic up that reminds us that yes, it would be great to get students to engage in formative assessment, but of course that means we have to mark it.